first speaker of the two speakers. Ingo Stelzer is Senior Technical Program Manager at Kuraray Europe. With more than 20 years of professional experience in the glass and facade industry, he has been involved into the realization of many glass construction projects and related R&D activities worldwide. He is also an active member of DIN, EN, ISO code work groups, respect, that's a lot, and other industry associations. In 2000, he received his engineering degree at the University of Hanover. Positions before joining Kuraray have been at Dupont de Nemours as senior consultant and Sailor Group as head of the glass processing division, CEDAC. And then our second speaker is Michael Kraus. Michael Kraus studied civil engineering from 2008 to 13 at the Technical University Munich. From 15 to 19, he has been working at the Institute and Laboratory for Structural Engineering at the Bundeswehr University of Munich. In February 2019, he defended his PhD thesis on machine learning techniques for the material parameter identification of laminated glass in the intact and post-fracture state. In January 2020, he joined Stanford University in the US to collaborate as a postdoc researcher with Professor Christian Linder in the field of applying artificial intelligence on modeling of materials and structures. And currently, you're at ETH Zurich. Thank you.
Okay, thank you very much, Valerie, for the nice and quite long introduction, because we are two speakers. So, ladies and gentlemen, good morning. So I will just say a few words as an introduction, and then I will hand over to Michael. So our topic is the SOUNDLAB AI Tool, which is a machine learning tool for sound, for the prediction of sound values of laminated glass, but not only, also IGUs and monolithic constructions. So what was our motivation? So as a starting point, so Kuraray, advanced interlayer solutions. So we have since nearly 20 years online tools available. So they are available for everybody on our homepage. And many years ago, we started with a structural tool, which was our strength calculator, which was a tool for the structural properties for laminated glass constructions. And over the years, we developed more online tools, so like the Trosifol WinSLT, which is a tool for the calculation of light transmittance and energy properties. Then in the next step, we introduced the Trosifol Glass Global, which is a structural tool according ASTM and DIN standards. And so they have been well accepted by the market and our clients. And over the years, there was more and more the wish to have only also a tool available for the sound prediction or calculation of the sound properties of the laminated glass constructions. And so far, there was nothing really available on the market. So it's okay, that's okay. So we did a testing of the tools available on the market. So there are just a few, but we figured out that most of them do not have the required properties, so they are maybe quite good to calculate the properties of a brickwork construction or something like that, where it doesn't matter if you have a prediction accuracy of plus minus 2 or 3 dB, but it's too big for the prediction of glazing constructions. And then there are some more advanced solutions available, for example, finite element based, but they are quite complex to use. And especially the potential calculation time would be much too long for an online tool, because it's very important to say for online tools it must be quick. So the user wants to have the results immediately and not after 10 or 15 minutes. So I have some problems with, okay. No, it's switched back. And then the first approach was to develop a data-based solution because we have hundreds of test reports available. So we developed the first so-called SOUNDLAB solution, which was the database tool where you can figure out, okay, these test reports for these and these constructions are available, and then it gave you the results and also a download function for the test records. But as you can imagine, there's a huge potential number of glazing constructions which you cannot cover with, it would require thousands of physical tests in a lab, which is just too much. And then the second approach was to develop an AI-based tool in combination with the existing database. And since many years, so we had a quite good relation with M&M. M&M, it's Michael Kraus and Michael Kraus, so the two founders of this startup. And then we had some sessions where we created a potential solution for this new AI-based tool. So, and here I would like to hand over to Michael.
Thank you, Ingo. Yeah, welcome everyone also from my side. Nice to have you here, and I will walk you through the technical details of the SOUNDLAB AI tool. And let's start with the buzzword bingo as usual in AI. And a lot of you, I think, already know. Okay, does not work. So AI has been around like the 60s, but it never made it really into practice. And we since like 10 years in research, but also in our company, deal with how can we as civil engineers make sensible use of the tools which are provided here, which in theory or basically are mathematical models. And the idea of why not go with established solvers like the finite element method and so forth, as Ingo already outlined, is that we need speed. And for that we said, okay, let's rely on this combination of a model, which comes from the machine learning model, and the database. And the other thing is, why go to AI in the broadest sense? We have seen a lot of developments in computer vision, speech recognition, and so forth, where we could really see that the models which are provided under this umbrella, they really supported a lot. And you can see that in healthcare, finance, and so forth. So the idea was, okay, let's go there, investigate suitable models, and put it onto our database and evaluate how well that works. To just give a brief overview of the nomenclature, because the term AI is too broad, what we do is classical machine learning here, and specifically we are in supervised regression, which every one of you has already done. So the first machine learning model you already have solved potentially during your studies. And I just want to show with that slide that machine learning offers a wider range of what potentially you have seen during your education. And this is, I think, where it really gives us new opportunities to come up with good models. And it makes sense if you have data and a problem to look into machine learning. However, do not just use machine learning for the sake of being en vogue. Because in our experience with industry-based projects, you always need three things to be fulfilled so that really machine learning offers an advantage over established method. And that is that for sure you have data available on your problem, which we had with the database, as Ingo said. And that this data, they hold the pattern which we are looking for, like the sound insulation values. And if there is a simpler way of doing that, always do the simpler way, do not use machine or deep learning. Because there is a lot of things which have to be done if you want to use machine and deep learning, and if there is a simpler model, always take that. So we established already that there is no simpler solution to predicting the sound insulation value at a certain accuracy given a limited amount of prediction time. So we went and tried to establish the standard steps in a machine learning project, which is let's look at the data, do some pre-processing, and the core step then is to extract meaningful features. We will see that in the next slide. So features means that describes your problem very well. That could be the glass setup, that could be the type of interlayer. But as you may know, deep learning has shown us that, for example, in pictures, the obvious features like colors don't necessarily are the best to describe the problem. So an essential part of the project went into finding and defining good features from the data set which we were provided. And then there comes a more standard part of the process, which is training different models. We will see also that a bit later, because we want to find the best predictive model and integrate that as an online tool in the case of Kuraray. So I think a key message of this talk is that data-driven methods like machine or deep learning always rely on having a good data source and doing this feature engineering step properly. If you don't do that because you want to spare the money, you are having the risk of that your project is not delivering a very good model. So we spent quite some time in going through the database and looking into the types of features, which is the glass thickness, the interlayer thicknesses, the interlayer types, and if you have some insulated glazing units, also the cavity and the gas. And if you look a bit more careful, we have also to define the nature of the feature type, which can be a continuous number, which I think most of you are used to deal with that. But machine learning models depend also if you have categorical variables, because these kind of variables, they introduce some necessary pre-processing steps. For example, in our case, we had to find out which way of encoding the categorical variables delivers the best model. In our case, that was one-hot encoding. I have unfortunately not the time to tell you more details on the different feature encoding methods we looked at. But I think the thing here to remember is if you have a mixed problem type, as we had here, you have to spend some time on finding a good way of encoding the features of the feature engineering, which we did. And we also investigated if we could get rid of some of the provided database features. Because, as I said, if there is a simpler model, always use the simpler model. We did that here via correlation analysis and looking at the predictive performance in the sound insulation values. And what we saw is that we really needed all the features which were provided, because, I mean, that's for sure, if you have an engineering background, it really much depends, the sound insulation value depends on the type of glass setup, right, and the gas filling and so forth. So if you remember my process chart, we have done now the feature engineering, did that very well, I think. Now we come to the modeling part, which I said is more standard. We tried as baselines simple linear regressors, as you may know, just straight lines for predicting, and compared that to decision trees and an ensemble version of decision trees, the random forest regressors. Here you can see the difference between one single decision tree here. So the idea would be we feed the features to that decision tree, and in the end, it learns how to differentiate the different feature values and predict me the correct sound insulation value. And a single decision tree, as you may expect, does a job in some parts of the database very well, but maybe misses other parts of the database. So an ensemble method like the random forest approach seems naturally, and we also investigated that. To reach a robust prediction, because as Ingo already outlined, the request from Kuraray, in addition to the speedy prediction of the sound insulation value, was to stay within a certain uncertainty level in the prediction, which was 1 decibel, and we had to reach that. So we are at the stage of scanning different machine and deep learning models against the baseline model, a very simple linear regression. And maybe you have seen these 45-degree lines plots before, where we have the measurement of the data set, like the ground truth, and our prediction value on the vertical axis. And the better your model predicts, the more you're on this black line. So in the best case, you repeat with your model the black line, and the scatter around the black line is very low. As you can see, with the simple baseline linear regressor, you're doing a bad job introducing also heavy bias towards certain regions of the prediction. And with the random forest, we get closer to being to this 45-degree line, but still we are not having a good model. But what we established now is that we should really go with the ensemble method and spend a lot of time in fine-tuning that. And that is the next step. As I said, we don't have too much time to go into all detail. We used fivefold cross-validation to find the best decision tree model, tweaked a lot of hyperparameters, spent some time on finding the best model. And what we found is that the model has to have a certain depth, but not too deep, because as I said before, if you have a simpler model, which has similar performance, always take the simpler model, because that saves space and time in the prediction. So what we have done now is created our features, looked into the database, and trained a good model. And now it comes down to meeting the customer requirements, which was accuracy and speed. And for that, I want to show again two plots. One is the predictive capability of the finely tuned random forest, which you can see here. So we really have no bias, because this red line, which is the mean prediction overall glass setups, is pretty much sticking to the 45 degrees line. So on average, we are not doing any error. And the scatter around that, indicated by the R-square value, is really low. Still, we have to quantify if we stay within the 1 decibel bound. And therefore, I provided you this plot. And if you do the statistics and look here for the cumulative distribution function, you actually will see that 90% of the errors, or 95% of the errors, really stay within the 1 decibel requested uncertainty bar. So from our side of doing the modeling, I think we achieved what was requested. We delivered a speedy model, which does a very good job at predicting. There is no average error, and the uncertainty in the prediction stays below the requested 1 decibel level. And in order to show you the implementation on the homepage, we would have a video which hopefully plays, and later you can also scan this QR code and test it yourself on. Oh, maybe I did break something here. Can someone play the video? I will go to that slide. Yeah, here it is. So what we show you here is how easy it is to really put in your setup of the glass, and then you will see in live the predictive speed and the test reports which you can download. And I chose an example here which we also have in the database to give you a comparison of the accuracy and what you can do in the end. As requested by Ingo, was you can really download the prediction report, provide it to your customer if needed, and if we have that, we also would provide you the test report for the process. And as I said, we have the QR code. Feel free to also try it yourself. And this brings me or us to the conclusion. I would say, at least from our side, M&M, we think we have achieved all objectives in terms of accuracy, speed. And I think handing over to Ingo again for the conclusions.
Yeah, so thank you, Michael. Yeah, so we launched the tool around about 2 years ago. The initial idea was to launch it for the GPD 21, but we all know that GPD been shifted 2 times. So now we have 2 years experience, or our users have 2 years experience with the tool, and I think that the feedback from all over the world. It's quite positive, so they are almost very excited. And we have more than 1,000 users per month, so the number of users is still growing because more and more they are aware about the tool. By the way, you can use it also on your mobile device, so it's also working. And so all over, I have to say thanks to M&M. So it was a great cooperation and also the outcome. So this tool, so we are really satisfied with it. And what is the outlook? So of course we will have to do maintenance and further development of the database. So when we will have new constructions, we will add them to the database, which will even improve the accuracy of the tool. Then we are thinking about of adding additional functions to the tool. So we are getting also requests from our users, so about having functions. And then I think the biggest goal for the future will be, because at least in the European Union, so there's a new EN standard under development about the glazing and airborne sound insulation, so a validation procedure for calculation tools. So this new standard is still in the early developments, but so this standard will be, I think, most important for us to adopt the tool to these standard requirements. Yeah, so that's it from our side. So thank you very much for your patience and interest.